Hello student, this is the second part for important diagram for physics. First graph is between magnetic field and distance r, or you can say radius. B is directly proportional to r for this region and B is inversely proportional to r for this region. What is the topic for this? The topic for this is the magnetic field due to a thick wire of a uniform cross section. We have a wire and this wire is current is uniformly distributed along this wire. Here we take three regions inside the wire, outside the wire and on the surface. For r less than a, magnetic field vary according to this. It means B is directly proportional to r. For r greater than a means we consider a ampere slope just outside the current carrying wire. For this B is inversely proportional to r, and for r equal to a the magnetic field is maximum. So for this one the graph is this. B is directly proportional to up to the surface of the conductor and it is inversely proportional to away from the conductor. Next I have another graph that is very important, and this graph is belong to what? This graph is belong to this topic, force between two parallel current carrying conductor. Here we have two conductor, one is having current I1, another is I2. Both are separated by distance d. If direction of current are same, then they are attract to each other. If direction of current are opposite, then they are repelled to each other. So force per unit length is given by mu naught I1 I2 divided by 2 pi d. It means that force is directly proportional to the product of the current and inversely proportional to the distance, or you can say separation between the conductor. So how you draw the graph? The graph between force and the product of two current. This product of current either may be positive or negative. If both are positive means both are having the same direction. So we take force and current graph like this, because this is attractive force, and for attractive force we take always negative. And if current is flowing in opposite direction, it means they are repelled to each other. And for repulsion, I1 into I2 are taken as negative because one is direction positive, then another one is negative. But force is positive, so we take this graph. Now this graph is for what? Force is negative. Force is negative means for having the conductor current, direction of current is same. So this is the graph. And for the conductor which are having current in opposite direction is given by this. Next graph is for induced EMF. So as you know that this is the graph for induced EMF. EMF is equal to minus L di by dt and flux is given by L into I. So induced EMF always have opposition for change in current. Negative sign is here, opposition. And flux is directly proportional to the current I. So how we draw the graph? If we take di by dt is positive, the induced EMF is negative. Induced EMF is directly proportional to the rate of change of current. Next graph is between flux and current. This is the magnetic flux and this is the current. As we know, in case of inductor, the flux is directly proportional to the current. Next I have a graph between energy density, energy stored in an inductor and current. You know the formula, energy density is equal to half Li square. What is the L? L is here inductance, self-inductance, and I is current. So energy is directly proportional to the square of the current. It means it always follow parabolic path. Next I have two more graph. One is between XL and frequency and second is XC and frequency. So how we relate these two? For XL is equal to L omega. And how we write L omega? L omega is write as 2 pi nu, means 2 pi frequency. Now what is the relation between the frequency? The frequency XL is directly proportional proportional to the frequency. Behalf of the frequency, we divide two type of current. One is AC and another one is DC. So DC always have frequency 0. It means for DC XL equal to 0. Means easy path for DC. And for AC frequency is not equal to 0. It means XL is not equal to 0. It means always oppose the AC. So it always oppose the AC. And what is the relation XL and frequency? They are directly proportional to each other. For XL and frequency, the graph is directly proportional to each other. And but what about the capacitor? For capacitor, XC is written as 1 by C omega. And 1 by C omega is what? 2 pi F. So for capacitance, reactance of capacitor frequency is inversely proportional to, means this behaves just opposite to the inductor. Inductor provide easy path for the DC current, but capacitor, you know very well, it store charge, so it does not pass the DC but easily pass the AC. This one is the graph. And next is graph between resistance and frequency. You know very well, resistance doesn't depend on the AC current or DC current. It always opposes the flow of current, so it does not depend on the frequency. This straight line show that resistance is always same for any value of frequency. Thank you.